Okay, so this is 6.1 for 0965, Math 0965. I'm Stroop. This is 6.1, greatest common factors and factoring by grouping. Okay. So first, we'll work with just factoring out the greatest common factor. So factoring out the GCF. And all it truly is the reverse of distribution. So instead of multiplying in something, you're kind of dividing something out. Get a better pen here. My pen is dying. Okay. So yeah, recall then distribution problems that you saw in the past. What the heck was that about? Let's take a look at an example. Maybe we had something like 3x to the fifth times 2x plus 1. Okay, so to distribute, we multiply this times this. So multiplying the constants together, 3 times 2 is 6. And then multiplying the variable terms together, x to the fifth times x. You add the exponents and you get x to the 6. Okay? And then 3x to the fifth times 1 is plus 3x to the fifth. Okay, so now we want to go in the opposite direction. We want to identify this thing, the biggest thing that is in common to both of these terms, and unmultiply it, basically. So now we want to reverse the process. And that happens a lot in math. Want to do it one way and then turn around and do it the other. Okay, so let's take a look at an example. And I just want to give you the end goal, and then we'll take this example apart and kind of do piece by piece. We'll be looking for the greatest common factor, and that'll be our next section. We'll worry about that. But just for now, I'll tell you it's going to be 3x. Okay, it's the biggest thing that divides into both this and this without leaving any sort of remainder. Okay? So 3x. And then you could set it up like this as a fill in the blank. You say to yourself, 3x times what is 9x to the third? Well, that's 3x squared. And then 3x times what gives me 3x. Okay, so that's just 1. Okay, so that's our goal. That's where we're headed. So how did I know to pull out the 3x is kind of the question everybody asks. And well, I just identified the greatest common factor between these two terms. So that'll be our first sort of issue on the list of things to do today. So finding the greatest common factor, I'll just write GCF again. And we'll take a look at, this is kind of a slow method. Eventually you want to do it in your head without having to go through all this process. But just in the beginning, it's a good idea to kind of do it piece by piece here. So let's say we have two terms, 12x squared and then 8x. Okay. So to find the GCF, what you do is completely factor it. So 12x squared is the same as like 4 times 3 times x times x. And then this is factored, but it's not in its smallest form, right? It's not like a prime factorization. So I could break down the 4 a little bit. So I could say that's 2 times 2 times 3 times x times x. Okay. Now this thing is completely factored. I want to do the same thing with 8x, right? So 8 is the same as 4 times 2 times x. And then I could break down the 4 just like I did over here, and I get 2 times 2 times 2 times x. So what? Well, the greatest common factor then is the thing that is in common to both of these terms. So both of them have two 2's, so the GCF, there's going to be two 2's, and then there's going to be one x term in common. So the greatest common factor, when you multiply this out, turns out to be 4x. And some people like to circle it, you know, okay, this is the stuff that's in common, and then also we have this. Okay, let's look at some more examples. So I like to do a lot of examples. Here's problem 7. I have 9y to the 5th, and then 18y squared. Okay, and I'm just going to do the same thing. I factor them into a prime factorization, and then I pick out the common elements. Okay, so 9 is really the same as 3 times 3, and then we have y to the 5th. So there's 5 y's being multiplied together. And then 18y squared is the same as, and I'll go ahead and cut to the chase. 18 is 3 times 3 times 2. If you don't remember, you can go over and do a factor tree. So 18 is 2 times 9, and then 9 is 3 times 3. And your factorization is right here. Okay, and then y squared. So I have then times y times y. The GCF, the commonality here then, well, let's look. There's 2 3's that are the same. So the GCF will have 3 times 3. And then also 2 y's. So y times y times y. Okay, so 3 times 3 is 9. Y times y will give you y squared. Okay, let's look at one that has now 3 terms, and we need to find the GCF of all 3. So it's problem 9. And in particular, then we have xy squared, and then xy cubed. So we have multiple variables this time. I do the same process, okay? So x times y, it's already factored basically. I'll just rewrite it, x times y. And then xy squared. So that will be x times y, and then xy cubed. So that'll be x times y times y times y. Okay. And then again, you just look for what's common instead of just looking for what's common. The 2 of them, you look, it has to be in all 3, right? So x is in all 3. So our GCF will have an x. And then y is also in all 3. So we'll need a y. And we could write x times y with the dot in the middle is the same as writing x, y. Okay. All right, let's look at a hard one. So I'm a harder guy. This is number 12 from the book. We have 18 x to the 5th, y to the 4th, and then 6x to the 6th, y cubed. And then we have 12x to the 4th, y to the 5th. Okay, so it's just business as usual. I'm going to sit here and I'm going to factor them, and then I'm going to look for the common factors that exist in all 3 terms. Okay, 18, as said before, is 3 times 3 times 2. And then we have 5 x's. Instead of writing it out, that seems like a bit silly, right? So let's just write x to the 5th and then times y to the 4th. Sometimes you show every small detail, it gets kind of confusing. So let's just keep it, x to the 5th. And we know there's 5 x's here, and then there's 4 x's here. So then we have 6x to the 6th times y cubed. Okay, so 6 is 3 times 2. And then I have this time 6 x's and then 3 y's. And then for the last guy, 12x to the 4th, y to the 5th. Well, 12 is 2 times 2 times 3. And then x to the fourth, and then y to the fifth. Okay, so for our GCF, the constant terms, the number terms, we have a 3 in all three of them, so we need a 3 for our GCF. And then there's a 2 in all three of them, so I need times 2. And then for the variables, what you do is just look for the lowest exponent. So each one of these, there's 5 x's here, 6 x's here, 4 x's here. Each one of them is going to have 4 x's. So the general rule then is just look for the lowest number exponent. So here it would be x to the fourth. And then for the y terms, it's going to be just y cubed. Okay. We don't want to write our GCF like that. We want to multiply it out. So we'll actually have 6 x to the fourth, y to the third. And that'll be our GCF. Okay, so that one's a little harder. There it is. Okay. Once you get the handle of identifying the GCF, and hopefully after a while you won't have to write it all out like this. You'll just be able to kind of look at it and know. After a while, you'll be able to factor it out and or to identify, and then we're going to want to factor it out. So again, it's the reverse process of distributing. So here we have factoring out the GCF, and we'll take a look at 13. Okay, so 13 we have 8x plus 8. Okay. You still need to do the game here. You have 8 and 8x. The factor that's in common to both of them is 8, right? So if you wrote it out, 8 is 2 times 2 times 2, and then times x. And then here, 8 is 2 times 2 times 2. So the only thing in common is the 8 part. The x is not in common to both of them. Okay, so what you're going to do is write the common factor, the greatest common factor, and then put some parentheses, and you can think of it as a fill in the blank. You're saying 8 times what is 8x? Okay, well, 8x. And then you're saying 8 times what is 8? That's just 1. Okay, and so you factored it. You want to check your factorization by redistributing. Okay, and I just do that in my head. I say 8 times x is 8x, good. And then 8 times 1 is 8, so yeah, I got it. Okay, and then I move on to the next problem. Okay, so here the thing that divides both of them, and the GCF, well, I could say 2, but that won't be the greatest common factor. The biggest number, or the biggest expression that divides in both of them, is actually 4. Okay, so put a 4 on the outside of the parentheses. And then I say to myself, 4 times what is 4y? Well, y. And then 4 times what is negative 4? Well, minus 1. Okay. So we'll just keep looking at a whole bunch of examples, and hopefully you can sort of catch on to what's the game, what's the deal here, what am I doing? So I have 21 x squared plus 5x. Okay, so what's common to both of them? There's no number that will divide into both of these guys, right? So it's just going to be a variable. This one has x times x, this has an x, so there's just one x I can pull out of both of them. And then again, you could do it like a fill in the blank. You ask yourself, x times what is x squared? Well, that's just x. And then x times what is 5x? Well, that's just 5. Okay. Let's keep going. 25. We have 14x cubed plus 21x squared. Okay, so I want the biggest number that divides into both of them. That's the GCF. That's the thing we were finding by doing the factorization and circling numbers. You could also think of it as just the biggest thing that divides both. Okay, so what's the biggest thing that divides both? Well, 14 and 21 are both divisible by 7. So I bet that's the constant part. And then the biggest variable that will divide x cubed and x squared is x squared. then I'll set up my parentheses, put a plus sign in there, and start thinking 7x squared times what is 14x cubed? Well, 7 times 2 is 14. X squared times x is x cubed. 7x squared times what is 21x squared? Well, times 3. Okay, so 7 times 3 is 21, and then the x squares, looks like it works. 29. So I have 9y to the 4th plus 27y to the 6th. Okay, it looks like 9 will divide both of these numbers. So the constant part of the GCF is 9. And then the biggest variable term that I'll go into is y to the 4th. Okay, so again, as I said before, when we were doing the long sort of version of this, you look for the lowest exponent. Okay? And then it's, well, in this case, it's just 1. 9y to the 4th times 1 gives me 9y to the 4th. And then 3 times 9 gives me 27. And then for the y to the 6th, I need to multiply y to the 4th by 2. Let's do one that has 3 terms now. So some of our factorizations had, we were looking at 3 terms. Okay, so here's an example of one of those. We want a number that divides 100, 50, and 100. Okay, so obviously 10 would divide all 3 of those, but greatest common factor, we want the biggest number that divides all 3, so 50. And then for the variable part, you just look for the lowest exponent, so the y squared. And then you could work it like a fill in the blank. So 50y squared times 2y cubed. And then we're going to need a y here. So y squared times y to the 1. Add the exponents, you get y cubed. And then finally, 50y squared times 2 should give me the 100y squared. Okay. The software will try to trick you, of course. They'll throw some problems like this at you. There's no number other than 1 that will divide both 11 and 23. Both those guys are prime, so there's nothing that will divide both of them. And there's no variable in common to both either. So there's nothing to do here. It's like basically not factorable. Okay, so the software will probably give you an option that says you're not able to factor it, and that's fine. Okay, so it may not be the case that you can actually find something. NCD means no can do. Okay, it's not a technical math term. It's what my teacher used to say. All right, so 45 is 30x squared y cubed minus 10xy squared, and then plus 20xy. Okay. So again, we're looking for something that will divide all 3 numbers. Here it looks like 10 will divide all 3, and it's the biggest number that does that. Oops. Then I need my variables. Okay, so it looks like each one has a factor of x, and then each one has a factor of y. And then it's a fill-in-the-blank problem. So you'll say, all right, I need 3. 3 times 10 is 30. And then I need another x, and then y times y squared. And then I need a y. 10xy times y is 10xy squared. And then I need a 2. Okay. Okay. One sort of problem that comes into play later on when you're doing more serious work is negatives. Okay, so to keep carrying on, sometimes you'll want this guy right here to not be a negative for purposes that will be shown later. Okay, so we need to know how to factor out negatives and basically work with those issues. So that's section 4 in my notes, factoring out negative leading coefficients, or factoring out negatives, basically. Okay. So let's look at number 50, and I'll give you a better idea of what the heck I'm talking about. I got negative 15 x squared plus 20. Okay. So I want to factor out a negative. I don't want this first guy to be negative for reasons that, well, like I said, we'll talk about it later in life. But for now, you're just going to have to accept it. I don't want a negative in this first position, this pivot position, pole position, right? So I'm going to factor out a negative with the GCF. All right, so I just slap a negative in there. Then I'm saying what divides both of them. Looks like 5 will go into both of them. And then there's not a constant common to both of them. So now it just becomes a fill in the blank. But you have to be a little careful because now the signs get flipped. So before it was negative, now this thing will be positive, 3x squared. Before this thing was positive, when I go over here, now it's going to be negative because I pulled this negative out of both terms. So I'll have negative 4, and then you probably want to check it. When you're first starting, it's not a bad idea to check it in your head. Negative 5 times 3x squared is negative 15x squared. So we should get back to here. Negative 5 times negative 4 is positive 20. Okay, let's try one more. So I got negative 8x to the 4th plus 32x cubed plus 16x squared. Again, this is one of these factor out the negative problems. Right? So I'll pull a negative out, and then what's common to all three? So I think 8 will divide into all 3 of them. And then each one has at least x squared in it, right? They at least have 2 factors of x. This has 4 factors, this has 3. So I could pull out x squared out of all of them, and then it's fill in the blank, right? You just have to be careful, change the signs. So x squared, and then instead of plus, it's minus now. And you got 4x, instead of plus, it's minus now, 2. Okay, so that's pretty much the GCF stuff we had to worry about. Now we want to move on to something called factoring by grouping. So basically what we're after eventually is doing the reverse of a FOIL. So when you FOIL something first, outer, inner, last, what were you doing? You're multiplying out, x plus 2 times x minus 3. We want to do the same business, but in reverse. So if you multiplied it out, you would get what? X squared minus 3x plus 2x minus 6, which would be x squared minus x minus 6. So hopefully you learned how to do that in your last class. Okay, maybe you need a reminder, but I think it's in there in your brain somewhere. So in your last class, you went from here to here. Now we want to go in the opposite direction. So you used to go from there to there. Now we want to go from there to there. Okay, that's what all this is leading up to. So the first step in there in this process is kind of play around with it, is this factoring by grouping technique. And instead of factoring out just a number or a variable, what we're going to be doing is factoring out a whole binomial. It'll look kind of weird at first, but you'll get the hang of it. Okay. So for example, 57, we have x times x plus 5 plus 3 times x plus 5. Okay. So you have to imagine, what are we dealing with here? We have this as our first term, Right? Just like up here, this guy was our first term. And then this entire big thing, it looks like it's a lot more than just one term, but it's really just one thing. Okay, just like this is the second thing, and then this would be the third thing. Okay. This guy and this guy both have something in common. And what do they have in common? It's, well, hey, it's kind of obvious, isn't it? It's that x plus 5 thing. So, hey, why not factor that thing out? Okay, why not pretend that's the GCF and rewrite it? Okay, so we'll have x plus 5 pulled out. And then the leftover bits, well, when I factor out the x plus 5, what are you left with? You're left with x. When you factor out the x plus 5 here, what are you left with? Well, you're left with the 3. Right? Okay, so in a way, what we're doing, like I said, is we're kind of trying to end up at the position where you would have normally have done a FOIL. Okay? Okay, and that's pretty much it. And look, if you redistributed this thing, you know, this whole thing times x is going to give you this first term here. Okay? When you multiply this whole thing times 3, what does that give you? Well, that gives you this term back right here, 3 times x plus 5. Okay? Maybe you think it's x plus 5 times 3, but it's the same thing. It's like 3 times 5 is the same as 5 times 3. Okay, let's look at some more. So here's 61. We have x times y plus 6 minus 7 times y plus 6. Okay, so this time we want the y plus 6 to come out. So that'll be my greatest common factor, the y plus 6. And then what's leftover parts? Well, it's the x and then minus 7. There's your answer right there. Just by covering up the y plus 6s, you can see your answer. For, I mean, what goes in here. It's not your answer, but okay. So what did I have left? It was the x minus 7. Right, so once we accomplish that feat, we take it one farther step. Okay, so problem 70, here we have x squared plus 3x plus 5x plus 15. Okay. So I want to turn this problem into a problem that looks like number 61. And how do I do that? Well, I'm going to factor the GCF out of those two, and then I'm going to factor the GCF out of those two. And I hope they'll have a common binomial. Right? So what do I got then? Factor the x out of the first two. Okay? That'll leave me with x plus 3. And then plus, the common factor between these two is 5. So if you factor out a 5, you know, 5 times what is 5x? Well, x. And then plus 5 times what is 15? Well, that would be 3. So they both have a common factor of x plus 3, and we could factor that out. And then what's left over? Well, you can kind of just cover up those pieces, and what's left is the x plus 5. Okay, let's look at one more of those, and then we'll have an application to worry about. Okay. So 76, I have x cubed plus 6x squared minus 2x minus 12. Okay. So again, I'm trying to get this into a form where this guy has a binomial and this guy has another binomial that are the same. So you work two at a time. Okay? For the first two, I'm going to factor out the x squared. So this will be x squared, and I'm left with x plus 6. Right? And I can redistribute and see that that's exactly the same as this. X squared times x is x cubed. X squared times 6 is 6x squared. Now I'm going to factor out a negative. And it's imperative that you factor out a negative for you to have that common binomial. Okay? So negative 2 times what is negative 2x? Well, x. And then negative 2 times what is negative 12? 6. Okay, so you have to have this same binomial in each. A binomial, you know, it has two terms. Like bicycle has two wheels. Once you have that done, you factor out the x plus 6 is the GCF. And then what's left over, you got the x squared minus 2. Okay. Okay, so that's the idea. We want to take a look at a quick application. I think it's on page 434. Or maybe not. Ugh, my page numbers must be all different than yours. Well, maybe not. Let me see. It's number. Yeah, it's definitely not the same as yours. Weird. No, it is the same as yours. So it's on page 434. Sorry. It's number 97, and it's about an explosion. So an explosion causes debris to rise vertically with an initial velocity of 64 feet per second. And then they give you a polynomial to describe the behavior of the debris. Okay, so the polynomial 64x minus 16x squared describes the height of the debris above the ground in feet after x seconds. Okay, so part A, they want you to find the height of the debris after 3 seconds. Okay, so what is the height when x is 3, right? Because this thing will tell you the height for whatever x value in seconds that you want to know. Okay, so you just basically plug and chug. I'm going to plug 3 into there. Okay, so I'll have 64 times 3 minus 16 times 3 squared. Okay, and if you put that into your calculator, then you want to do order of operations correctly. 64 times 3, 192 minus 16 times 9. Okay, so 192 minus 16 times 9, I'll just do it with my calculator, it's 48 feet. Okay. So after 3 seconds after the explosion, the debris is 48 feet in the air. Let's see what else. Factor the polynomial. Okay, so factor, and that's just basically what we've been doing. So looking at this guy, 64x minus 16x squared, both terms are divisible by 8, but you can actually do better than that here. If you do it accidentally wrong, so let's say I just didn't see the greatest common factor, and I did this, 8x out of both of these is the same as what's left over. So 8 times 8 is 64, right? So I'll just have an 8 there, and then minus, well, 2x. And it's pretty clear now that this binomial has a common factor of 2. Okay, so you didn't get the greatest common factor, but you can factor out a 2 on top of it. So you can say, all right, I also need to bring out a 2. You have to be a little careful how you do it. You may want to just back up and rewrite it with a 16 out in front, if this scares you. So anyways, 8 divided by 4 is 8 divided by 2 is 4. In other words, 2 times 4 would have given you the 8, and then minus x. Okay. So at the end of the day, it's 16x times 4 minus x in the factored form. Okay, now they want you to use the factored form to find the height after 3 seconds again. Okay. So the point is, it's a little easier if you use this factored form than going through all of the arithmetic. Okay, so I think that's their point. So again, we want to find the height when x is 3 after 3 seconds. So using the factored form, then I have 16 times 3 times 4 minus 3. Do the parentheses first. Please excuse my dear Aunt Sally. So I'll have 16 times 3 times 4 minus 3 is 1. And I could do that in my head or in my margin. 16 times 3. 3 times 6 is 8. Carry the 1. 48. So 48 feet. And of course, that's exactly what I got here, but the difference was I didn't have to get my calculator out. So these factored forms, you're wondering why we even care. Well, one advantage is it makes your calculations quicker. So, back in the day when you're doing all your calculations by hand, that was a big thing. You want to get, it's like any other job. You want to get your job done fast so you can go home and see the kids and see the wife. You can't do that if you're spending all day long fooling around with your calculator trying to figure out these numbers. So, but somebody somewhere noticed when you're factored, it's a lot quicker. Okay, so there's a reason behind all this stuff, and sometimes it doesn't feel motivated. It's like, why am I doing this? But trust me, there's a reason to it somewhere. All right, so that'll finish off 6-1.